Wire rope has attained worldwide acceptance as one of the safest and most efficient ways of coupling loads to crane hooks and other lifting devices. Like any tool or machine used in construction, wire rope must be handled by skilled, trained personnel. Number one priority when handling wire rope has to be safety, both for yourself and your fellow workers on the site. When working with wire rope, wear protective clothing at all times. A hard hat, safety glasses, leather gloves, and safety shoes are all necessary to ensure rigger safety. The life expectancy of wire rope is often greatly reduced by improper storage and lubrication. Here we show properly stored wire rope slings, neatly oiled and hanging in a clean, dry place indoors. This prevents moisture damage and deterioration from dirt or other foreign materials which can abrade or corrode a cable. This is how not to store slings. Not only would it be hard to find the sling you need in this mess, but you would have to seriously question the lifting ability of any cable found in this condition. When manufactured, rope is lubricated both internally and externally. This lubrication is intended for initial storage and protection during the early stages of the rope's working life. This initial treatment must be continued with additional lubrication at regular intervals, as prescribed by the rope manufacturer. Always check with the manufacturer of your wire rope to determine the type of lubricant and type of application recommended to attain maximum life. Before talking about inspection of wire ropes, let's discuss the components of a typical cable. Wire ropes are made of basically three parts: wires, strands, and the core. The wires are twisted together to form the strands, which are then wrapped around the core to make the cable. It's important to know the difference between these terms to adequately understand what to look for when inspecting the condition of a wire rope. Another term you should be familiar with is one rope lay. One rope lay is defined as the distance it takes for a strand to make one complete revolution around the rope. Like cranes and other pieces of construction machinery, wire rope requires frequent inspections. These inspections are to determine if a wire rope is in suitable condition to perform the work to be done between scheduled inspections. Most government safety organizations in North America state that visual inspections should be done every 8 working hours, and that a thorough inspection should be done monthly. Accurate dated records of each inspection, noting damage, repair or replacement, and general condition should be kept on a current basis. The first sign of rope wear is usually broken wires. It is not uncommon to find the occasional broken wire in almost any wire rope. This in itself is usually not cause for replacing the rope. Location of the broken wire should be noted in the inspection records and watched carefully for any further breaks. Before inspecting a wire rope, you should first clean the rope so dirt and lubrication deposits do not hide broken wires or other damage. You must also remember to inspect the entire cable for damage. Make an effort to inspect the hard-to-get-at areas, such as the first few wraps on a hoist drum, or the underside of the outer strands and the core of the cable, which could have damage that is not always noticeable with just a quick look. In running ropes that pass over sheaves or wind on drums, the rope must be discarded if there are 3 or more broken wires per strand per rope lay. It must also be replaced if there are 6 or more broken wires randomly spaced per rope lay. Remember, a rope lay is the distance it takes a strand to make one complete revolution around the rope. For standing ropes or pins, the rope must be discarded if there are 3 or more broken wires per rope lay. Again, the entire length of rope must be inspected to determine its ability to stay in service. Remember, taking a rope out of service too soon is wasteful, but keeping a rope in service beyond these requirements is unsafe and unlawful. Be sure to check all government regulations regarding wire safety and to their standards. Another important area of the wire rope to inspect is near a socketed connection. One or more broken wires near an attached fitting is cause to replace the rope or to renew the attachment to eliminate the damaged area. The reason this area is so critical is because a wire rope is a working machine. Load on and load off of a cable causes much movement inside and outside as the strands work. Near an attached fitting, movement is restricted, and wear, such as broken wires in this area, requires immediate attention. In the last few slides, we have discussed broken wires in determining a rope's ability to stay in service. But broken wires are not the only criteria for removing a rope from service. A rope should be discarded if any of the following are noticed: kinks, core protrusion, bird caging, unbalanced wear, crushing, high stranding, or any other deformation of the cable which creeps its capacity. Another part of a wire rope inspection is to check the size of the rope. Wire ropes are measured for length and diameter, where diameter is measured at the widest point of the cable. The length of a cable is important because excessive stretch will cause the diameter to decrease, which could make the cable unsafe for continued use. Normal stretch, or construction stretch, is unavoidable, and some experts feel 6 inches or 100 feet is acceptable. If a cable stretches more than this, the diameter decreases to the point that strength lost and the cable could be too small for the sheaves, resulting in the wearing a rut in the support groove of the sheave. Remember, before replacing a wire rope on a crane, you should check the sheaves for correct groove size, or nicks, or dents, which could damage the cable. Also check the sheave alignment so the cable is not rubbing on the flanges of the sheave. Sheaves should also be checked to see that they have the freedom to rotate easily. A stuck or stiff sheave can quickly wear out hoist cable. Safety factors when dealing with wire rope are often abused and ignored, but mostly just misunderstood. All wire rope, when manufactured, have a breaking strength. By using this safety factor, we ensure that loads placed on a cable do not approach the loading limit that will break the cable. Let's look at an example. A 1-inch diameter cable built by a leading manufacturer of wire rope advertises a breaking strength of 42 tons. When we apply a safety factor of 5 to 1, usual safety factor for slings and chokers, we divide 42 tons by 5 to come up with a figure of approximately 8 tons. This amount, 8 tons, is what is commonly known as the safe working load, or SWL, of the cable. Why do we need safety factors when using wire rope? Well, there are many reasons, but some of the more important ones are inaccuracies in load weight. Many load weights given to operators and riggers are mere estimates, and by using a safety factor, this prevents us from loading a sling anywhere near its breaking strength. If you have doubts about the load weight, be sure to use a larger sling than appears necessary to ensure safety. Shock loading. Nobody shock loads a cable intentionally, but shock loading is a fact of life, and this can exert forces on a cable far greater than the actual load being lifted. Hurried starts and stops and load movement in the slings all constitute shock loading. Reduced capacity of the sling due to wear is another good reason for safety factors. Remember, sling capacity charts are based on brand new slings, and they are only new until they're used once. Reduced strength due to bending over sheaves. Anytime a cable is bent around a corner, such as a sheave, the strength of the cable is reduced. Safety factor accounts for this loss of strength. It should also be noted that end fittings and attachments are not as strong as the cable itself. Some are only 75% as strong as the cable itself. Let's look again at the equation for determining safe working load. SWL equals catalog working strength over safety factor. Safe working load is the maximum load that can be placed on a cable, and it must never be exceeded. There are many different safety factors for wire rope. We will look at and identify the ones necessary for cranes and hoisting. Slings or chokers have a safety factor rating of 5 to 1 in material lifting situations. The factor is 10 to 1 when handling men, either in man baskets or other personnel hoists. Running ropes, or ropes that pass over sheaves or wind on drums, have a safe factor of 3.5 to 1. This figure goes down to 3 to 1 in the case of a conventional crane boom hoist cable directing the boom. It returns to 3.5 to 1 when the boom has been raised. Standing ropes, or pendant lines, have a safety factor of 3.0 to 1 with boom erected and 2.5 to 1 when the boom is being raised. All operators and riggers should know the safe working load of every cable they are using and should never exceed these safety limits. A lot of attention has been given lately to non-rotating or rotation-resistant cables. These ropes are designed primarily for single-line use, such as a crane whip line, because they prevent a load from spinning uncontrollably while loading or unloading of the wire rope is taking place. These cables are manufactured with the outer layer of strands laid in one direction and the inner layer of strands laid in the opposite direction. This type of construction causes the strands to counteract each other and prevents spinning of the load. It should be noted, however, that rotation-resistant cables require special handling to prevent damage, such as core protrusion. There are many loading techniques that have been developed over the years. Let's look at the basic hitches, paying special attention to some good safety pointers. In the beginning of this presentation, we looked at how the condition of your sling affects its ability to perform to specifications. We can agree then that care must be used when rigging loads to ensure that slings remain in optimum condition for further use. One of the most common mistakes made is bending a sling around a sharp corner. This usually puts a permanent kink in the cable and has effectively reduced its capacity to 50% of its rating. Corners, or softeners as they are often called, should be used between the sling and the sharp edge to prevent this damage. The rule of thumb for going around a corner is to use at least one rope lay, or about 7 times the rope diameter. Anything less will cause permanent damage to the cable. Resting a load on a sling or running equipment over them are other common causes of unnecessary sling damage. Treat them with care, and they will reward you with long, safe service. Overloading is another prime cause of sling damage. By overloading a sling, you will damage it to the point of drastic capacity loss, even though it did not break at the time. An unsuspecting co-worker may attempt to use damaged sling without being aware of its deteriorated condition, and an accident may be the result. If the sling has been damaged and is unsafe for further use, cut the sling in half with a torch to prevent further use that may lead to accidents. A much overlooked area of rigging is sling angles. These are very important when determining what size sling is necessary to safely lift an object. Extra forces are generated on 2, 3, and 4-legged slings because of the tendency of the slings to pull together. When loaded, we will see how the angle of the sling affects the forces generated on them by the load. Here we have a 20-ton load suspended by a crane hook with a 2-point hookup and a low sling angle of 60 degrees. The letter F in the figure is the load exerted on each sling. Using a mathematical formula, we can determine F to be 11.6 tons at a 60-degree sling angle. Now, we'll take this same load and shorten our sling so the lower angle is now 45 degrees with the same 20-ton load. Using our formula, we can see F, the force generated on each sling, has risen to 14.2 tons per side, a dramatic increase. We now take this one step further and reduce the inner sling angle to 30 degrees. Again, we use our formula to find that F is now equal to 20 tons per side. From this, we see that sling angles are crucial for determining what size sling will be necessary for a given lift. Wire rope manufacturers provide detailed information in their sling capacity charts. These must be used and followed to the letter. A helpful way of maintaining inner sling angles of 60 degrees or better is to always make sure that the length of your sling, distance A, remains greater than the distance between them at the point of contact with the load, distance B. Very often in load rigging, we are required to use more than 2 slings, and a set of 4-way spreaders is required. Since 4-way slings are often not self-adjusting, load weight is sometimes carried by only 2 of the 4 slings, with the other 2 simply balancing the load. For that reason, it is best to calculate the sling size required, as though there are only 2 slings being used. Wrapping a sling around a load and putting one eye through the other to choke the load is a common error found in many rigging operations. Use a shackle to connect the lower eye to the running line. This prevents damage to both the choker eye and the running line. Notice the position of the shackle pin. It should never be placed on the running line, as the pin could work loose. Here is another practice which should be avoided. Never force the eye of a sling downward to tighten the hitch after tension has been applied. Damage to the sling is usually the result. Before attempting to lift any load, it is best to first determine the location of the center of gravity. This is the point on the load by which, if we put the load, it would balance perfectly. In other words, center of gravity is the center of the load by weight. In order for a load to be picked up without it rotating or flipping completely over, 2 things must be assured. The crane hook must be placed directly over the center of gravity, and the hookup points on the slings must be located above the center of gravity. Many accidents have been the result of failure to recognize these 2 requirements. One error we find on construction sites is the placing of 2, 3, or 4 slings onto one hook. This is an extremely unsafe practice. Hooks are designed to carry load in the widest part of the throat of the hook. Placing many slings on a hook has a tendency to open up the hook and weaken it to the point of failure. Always use a shackle when more than 1 sling is to be used in a rigging setup. The ANSI B30.5 regulation states that hooks should be inspected at regular intervals for cracks and other deformations. It also states that it should be discarded if the throat opening has increased more than 15%, or when a twist of 10 degrees is found in any hook. Here we see another common error on the job site. The rigger is using his hands to guide a load. If you can reach out and touch a raised load, you are standing too close. In case of a rigging failure or an upset of the crane, this rigger's chance of escape is very small. Use a tag line to control movements of the load and maintain a safe distance at all times. It is also wise to plan an escape route in case of an emergency. Never stand between a hard object and a suspended load. You could be crushed if something goes wrong. Never walk under a suspended load. Never ride on suspended loads. It is very hazardous and against law. Use the International hand signal system for directing movement of a crane load, and be sure to stand where the operator can see you and the load easily. Use only one signalman when moving loads so you don't confuse the crane operator. The largest single cause of rigger deaths in North America is power line contact. Be sure to check with your local electrical utility whenever work is to be done in the vicinity of any power line. Never stockpile materials near a power line. You may be aware of the line location, but the next person involved may not. Use care and common sense. This presentation has been designed to help keep your wire rope operating to its best potential and to show you safe rigging practices on a lift. For further information, contact our technical department. Thank you for your attention.